In this video, we're going to be learning how to diagram covalent bonds. First, we're going to do some Lewis dot diagrams, then single and double covalent bonds. We've already learned in this chapter how ionic bonds work. Today, we're going to move on to covalent bonds, which is a sharing of valence electrons to give them that full outer level. If you have not learned about valence electrons yet, this might be a little bit too much for you. This is assuming that you've already learned about those. We can diagram valence electrons using Lewis dot diagrams. Lewis dot diagrams are just a way to show how many valence electrons are surrounding an atom. Then once we do that, we can see what kind of covalent bonds can form when we make these bonds. So whenever we do Lewis dot diagrams, we always have to determine how many valence electrons are in each element or atom. A nitrogen atom, for example, nitrogen is in group 15, so that means it would be 5 valence electrons. So as I draw those 5 electrons surrounding this nitrogen atom, I just want you to observe the pattern that I use. I have 1, 2, 3, 4. So you notice how I did 1 on each side of the nitrogen, leaving a little space on the right, bottom, left, and top. And then as I do my 5th one, I start over at the top again, making 5. If I did 6, it would go here, 7 here, and 8 here, which is that full outer 8 that this nitrogen would want in its outer shell. So this is how you would diagram the Lewis dots for nitrogen. Chlorine is in group 17. It's a halogen, meaning it has 7 valence electrons. So I can do the same thing with chlorine. I start at the top left here, draw my dot. Next dot goes here, here, here. That gives me 4, meaning that there's 3 more. So I go here, here, and here. And then this would be the last spot that would be taken in the outer shell. You notice how it is pretty symmetrical? Just make sure that you always do 1 at a time and then do that second time around in that circle as we do Lewis dot diagrams. This will come in handy as we're doing some covalent bonds now. We're going to start off simple with some single covalent bonds. For example, a hydrogen molecule is a single covalent bond. As we've learned before, hydrogen only has 1 electron, and it would like to have that second one so it can get a full outer shell of 2. So what it does then, if there are no other elements to combine with, it can create a molecule with itself. It could find another hydrogen atom with 1 electron, and they can share their 2 to give them both an outer shell. So I guess the way that would happen is if this one turned this way, this one turned that way, they would be able to share those electrons right here in the middle. So that's kind of what happens over here. We have this hydrogen's electron right here, this hydrogen's electron right here. This kind of shows that they're sharing those 2. To show that they are bonded though, we actually opt in with 1 line instead of 2 dots. This line that we draw here shows that there's a bond taking place, that they're not just electrons here, but it's actually a bond, a covalent bond between these hydrogen atoms. So this is actually technically how you would show a hydrogen molecule. Let's try the chlorine molecule too. Just like hydrogen, chlorine is 1 electron away from having that full outer valence electron shell. So what it can do, just like hydrogen, is share with another chlorine atom. If they keep their own 6, for example, they can both share that extra one over here, and then that would give them that full outer shell. So as we redraw this, we're actually going to have to kind of rotate it again here. So these 6 are going to have to go on this side on the outside. Same thing with these. And then these ones over here are going to be in the middle to show that there's a bond there. So if we do the red ones first, we can do the 2 on the top, just like we did up here. These 2 on the side could be over here. These 2 on the bottom could be over here. Then I can show that 1 red one in the middle. And then the blues, we can have our 2 on top, 2 over here, 2 on bottom, and then we'd also have that one in the middle. So you notice how if this red chlorine shares this blue dot, and this blue chlorine shares this red dot, they now have 8 if they can share. And remember, we don't actually show this with the dots, we show this with a line to show that they are bonded. So each chlorine now has that outer shell. 1, 2, 3, 4, 5, 6, and this counts as 7, 8. Let's do one more single covalent bond. We have hydrogen, hydrogen, and oxygen. So this is how oxygen is drawn. If you remember, 1, 2, 3, 4, 5, 6 in its outer shell. Hydrogen each has 1. Well, if you notice here, this actually would work out pretty well. This oxygen needs 2 electrons. So if it shares with this hydrogen and this hydrogen, it would now have that 8 valence electrons that it desires. Each of these hydrogens just needs 1. And if you look, there's 2 kind of loose stray electrons right here on this side of oxygen and this side of oxygen. And that's kind of why we have hydrogen over here on this side where there's an opening, and hydrogen down here where there's also an opening. So if we draw that with hydrogen being red, we can have the hydrogen electron here, this hydrogen electron right here, and we can draw that oxygen atom in right here with its valence electrons. And if you look at this, oxygen now has 8, hydrogen has 2 just like it wants, and this hydrogen has 2 just like it wants too. Now we can erase these and show that they are bonds by drawing a big line. And that's how you show a water molecule. The 4 valence electrons for the oxygen, and then the 4 more that are being shared over here. Now let's look at a double covalent bond. For valence electrons, there's no rule about sharing just 1 electron. You can actually share 2 electrons, or in a way, 4 if you count the other ones. So when oxygen makes a molecule, for example, oxygen has 6 valence electrons on its own, as does this one. And if you notice in the Lewis dot diagram, oxygen only has 1 down here and 1 over here. So what if it combined with another oxygen? They can keep their 4 over here, and then they could share the bottom ones, and they could share the side ones. So that's what we can do. So if this hydrogen atom shares this one, we put that in the middle, and this one, we put that in the middle. This blue oxygen here shares this one, put that in the middle, and that one, put this in the middle. They now each have 4 left over to make their complete outer circle. And to do this, I try to make it balanced, kind of like a triangle here. You notice I have 2 here. I can put the other 4 here, so just so it's more of a balanced circle. And then the blue oxygen, same thing. So now if you count, remember these red ones are being shared with this oxygen, and these blue ones are shared with this oxygen. If I count the red, 1, 2, 3, 4, 5, 6, 7, 8, just like it wants. 1, 2, 3, 4, 5, 6, 7, 8, just like it wants. And remember, to show that these are bonds, I can erase these and draw 2 lines. This is for that first pair, and this is for that second pair. So this would be called a double bond. There's 2 bonds here. There's 4 total electrons being shared, and then the other 4 are made up by the electrons that the atoms already have. Let's do one more double bond. Let's take a look at the carbon dioxide molecule, for example. We see that carbon has 4 valence electrons, and oxygen, as we've seen before, has 6 valence electrons. So this is why carbon dioxide is made so easily. We see that oxygen here is missing 2, this oxygen is missing 2, so if you actually add those together, that's 1, 2, 3, 4 that are missing. Well, how many valence electrons does carbon have? Look, 1, 2, 3, 4. So that means these 4 electrons could be shared with the oxygen to give the oxygen each those 8 valence electrons that they want. And in turn then, carbon, which is missing 4, could share 1, 2, 3, 4 with the oxygen to also cause that to work too. So if we start with the oxygens, for example, which already have 4 that they are not sharing, I can kind of draw those in like a triangle format again. Whenever you have a double bond, you draw it like this. And then this one too also has 4 that it's not sharing. I now have those 2 extras that are being shared for each. So I can even draw that in here. 1, 2 for this one, and 1, 2 for this one. Now when I draw the carbon, I want to show that this carbon is sharing 2 up here and 2 down here, so I kind of split those up like that. So 1, 2, 3, 4. And now if I count my valence electrons, if they're being shared here in the middle, oxygen has 1, 2, 3, 4, 5, 6, 7, 8. And carbon also has 8. 1, 2, 3, 4, 5, 6, 7, 8. So everybody's happy. And remember, I need to show this as a bond, so I can actually draw 2 lines here, and then 2 lines here, and that would show that these are bonded. And as you actually can see, 2 double bonds.